The universe is an enigmatic and fascinating expanse, a vast playground where mysteries unfold constantly. In the grand theater of the cosmos, stars twinkle as beacons of energy, guiding us as we search for answers to the deepest questions about life, the universe, and everything in it. For centuries, we have pondered the possibilities of life beyond Earth, wondering if we are alone or if there are others, far more advanced, out there in the universe. Imagine a civilization so advanced that it has developed technologies capable of harnessing the power of an entire star, an energy source so vast it could fuel a civilization's most sophisticated machines, technologies, and wonders. This is the fascinating idea behind Dyson Spheres, proposed by the brilliant physicist Freeman Dyson back in 1960. These hypothetical megastructures, meant to surround a star to capture and utilize its energy, have long captured the imagination of scientists, science fiction writers, and enthusiasts alike. However, with the advent of powerful new technology, like the James Webb Space Telescope, the search for these Dyson spheres has moved from the realm of speculation to the frontier of scientific discovery. One of the most remarkable aspects of modern astronomy is how rapidly our technology is advancing, allowing us to probe deeper into the universe than ever before. In recent years, the James Webb Space Telescope, JWST, has begun to provide a level of detail and sensitivity never before seen. This revolutionary instrument has not only made breathtaking discoveries about distant galaxies, stars, and exoplanets but has also opened up new avenues of exploration in the search for signs of intelligent extraterrestrial life. One of the most intriguing possibilities that has emerged in recent times is the idea that some stars might be surrounded by enormous artificial structures that we refer to as Dyson spheres. The discovery of such structures would completely redefine our understanding of extraterrestrial civilizations and potentially offer us proof of life far beyond our own planet. The concept of Dyson spheres originated from the mind of Freeman Dyson, who suggested that advanced civilizations could harness the energy of their home star by constructing a massive sphere or network of satellites around it. This idea was built upon the work of Russian scientist Nikolai Kardashev, who introduced a scale to classify civilizations based on their energy consumption. Kardashev proposed 3 types of civilizations: Type 1, which uses the energy resources of its home planet; Type 2, which uses the energy of its star, through structures like Dyson spheres; and Type 3, which harnesses the energy of an entire galaxy. The construction of Dyson spheres, according to Dyson, would be the hallmark of a Type 2 civilization, an extraterrestrial society so advanced that it could control and utilize the energy output of its star. This power would not only support technological advancements but could also sustain an entire civilization for billions of years. While the idea seemed like science fiction for much of the 20th century, today, it's an area of serious scientific inquiry, fueled by increasingly sophisticated instruments like the James Webb Space Telescope. The concept of Dyson spheres is tied to the search for techno-signatures, unexplained signals or phenomena that might indicate the presence of intelligent extraterrestrial life. In the vastness of space, researchers are on the lookout for anomalies that cannot be explained by known natural phenomena but could be attributed to artificial structures or technologies. For decades, scientists have searched for evidence of such techno-signatures, which might include unexplained infrared radiation, unusual patterns of dimming around stars, or strange variations in space-time. As our technology has advanced, so has our ability to detect these phenomena. The James Webb Space Telescope is a key player in this quest, offering unprecedented resolution and sensitivity in the infrared spectrum. This means it can detect faint signals that were once undetectable, such as excess infrared radiation emitted by stars that might be enveloped in Dyson spheres. In 2023, astronomers using the James Webb Space Telescope uncovered compelling evidence suggesting that 7 stars in our galaxy are emitting unusual infrared radiation. These stars have been flagged as potential candidates for hosting Dyson spheres, as the excess radiation they emit cannot be explained by natural astrophysical processes. This discovery is a huge leap forward in the search for extraterrestrial intelligence. The stars in question are all M-dwarf stars, small, cool stars that are the most common type of stars in the Milky Way. These M-dwarf stars have several key characteristics that make them prime candidates for hosting advanced civilizations. Their long lifespans, sometimes lasting billions or even trillions of years, make them stable environments for the development of life. Additionally, their relatively low luminosity makes them ideal for harnessing energy through Dyson spheres. If Dyson spheres were built around these stars, they would be able to absorb and store energy for extended periods, providing a reliable and sustainable power source for any civilizations that may reside there. This discovery of 7 potential Dyson sphere candidates is just the beginning. When astronomers first noticed these unusual infrared signatures, they immediately began further investigations to understand what could be causing these anomalies. After analyzing the data, they concluded that the most likely explanation was the presence of Dyson spheres. This is an exciting development because it provides a new avenue for the search for extraterrestrial intelligence. For decades, scientists have speculated that such advanced civilizations might exist, but concrete evidence has always been elusive. Now, with the help of the James Webb Space Telescope, scientists are getting closer to finding that evidence. What makes these discoveries even more exciting is that they are not isolated incidents. The phenomenon of stars showing unusual infrared radiation has been noted in the past, with the most famous example being the strange behavior of Tabby's star, KIC 846-2852. This star became the focus of intense scrutiny a few years ago when astronomers observed its bizarre and unpredictable dimming patterns. At first, scientists thought that the dimming was caused by a cloud of dust passing in front of the star, but further analysis revealed that the dimming was too erratic and inconsistent to be explained by natural phenomena like dust clouds or comets. Some scientists even suggested that the dimming could be the result of a Dyson sphere surrounding the star, though this idea remains controversial. Regardless of the explanation, Tabby's star continues to be one of the most intriguing astronomical mysteries in recent years, and it highlights the potential for Dyson spheres to exist in the universe. The discovery of 7 additional stars that exhibit similar infrared anomalies is a significant step forward in this ongoing search for Dyson spheres. If these stars are indeed surrounded by Dyson spheres, it would mark a groundbreaking moment in our understanding of extraterrestrial life and technology. The idea that an advanced civilization could build a structure large enough to completely or partially enclose a star is awe-inspiring. Dyson spheres could potentially provide the energy needed for advanced spacefaring civilizations to travel between stars, colonize other planets, and perhaps even manipulate the very fabric of space-time. Such a discovery would not only revolutionize our understanding of what is possible in terms of energy generation but also offer tantalizing clues about the existence of intelligent life elsewhere in the universe. The process of identifying potential Dyson sphere candidates is not simple. Astronomers must sift through vast amounts of data to isolate stars that exhibit unusual or unexplained patterns. They look for signs like periodic dimming, excess infrared radiation, and irregularities in the movement of stars that cannot be explained by natural phenomena. This data is gathered from numerous astronomical surveys, including those conducted by missions like Gaia, TESS, and WISE. These missions collect massive amounts of data on millions of stars over long periods, making it possible for scientists to identify stars that exhibit characteristics that might point to the presence of artificial megastructures. Once these stars are identified, researchers use a variety of techniques, including spectral analysis, to study the data in greater detail. One of the key features scientists look for is excess infrared radiation, which would indicate that a star's energy is being absorbed and re-radiated as heat. This is precisely what we would expect from a Dyson sphere, which would absorb the energy of a star and re-radiate it in the infrared spectrum. The James Webb Space Telescope is particularly well suited for detecting this kind of radiation, as it is designed to observe the universe in infrared wavelengths with unparalleled sensitivity. By analyzing the spectrum of light emitted by stars, scientists can determine whether the radiation patterns deviate from what is expected from natural astrophysical processes. If the excess radiation cannot be explained by known phenomena, such as the emission from a star's surface or the presence of dust clouds, it becomes a strong candidate for being the result of an artificial structure. In addition to infrared radiation, scientists also look for other signs that might point to the presence of Dyson spheres. One such sign is optical variability, changes in the brightness of a star over time. This can occur naturally due to phenomena like pulsating stars, binary star systems, or the rotation of a star. However, a Dyson sphere would affect the brightness of a star in a way that produces a different frequency of variability than natural events. If the optical variability is completely absent, or if unusual patterns appear, it could indicate that the star is surrounded by an artificial structure. Another important clue comes from astrometry, the measurement of a star's position and motion. If a star is moving in an unusual way that cannot be explained by natural forces, it might be a sign that it is being influenced by an artificial structure, like a Dyson sphere. The search for Dyson spheres is part of a broader effort to detect signs of intelligent extraterrestrial life. While we have yet to find definitive proof of aliens, the discovery of unusual astrophysical phenomena like Dyson spheres or techno-signatures could provide the first concrete evidence that we are not alone in the universe. The James Webb Space Telescope, with its advanced infrared capabilities, is playing a pivotal role in this search. As scientists continue to analyze the data gathered by the JWST, they are inching closer to uncovering the truth about the existence of Dyson spheres and, by extension, the possibility of intelligent extraterrestrial civilizations. The idea that we might one day find evidence of Dyson spheres around distant stars is both thrilling and humbling. It challenges our understanding of what is possible in terms of technological achievement and opens up new possibilities for the future of space exploration. If Dyson spheres exist, they could be the key to unlocking the secrets of advanced extraterrestrial civilizations that might be far older and more technologically advanced than we ever imagined. The search for these enigmatic structures is just beginning, and the James Webb Space Telescope is helping to lead the way. As we continue to explore the cosmos, we may one day find that the universe is not as empty as it seems, but instead teeming with intelligent life and the remnants of civilizations that have mastered the art of harnessing the stars themselves.